Anyone remember from Monday what salinization is?
Yeah, salt in water.
Okay, good. So salt in water, salt in agriculture. You're going to get all sorts of things like salt and other minerals in your water, so it's pretty normal. But the overuse of crops or different types of irrigation, like we talked about the furrow and all that, yeah, good. All of that have to do or can create more salinization. So the very first part of your lab, maybe you can see my bowl. It gives you a bit of your background on salinization. It's bad for bad for agriculture, and it causes some of the problems. But you get salts, you get magnesium chloride, calcium chloride. Those are those other minerals I was talking about. When you irrigate, those minerals come out with the water. The water settles into the ground but leaves the minerals behind, and that kind of creates that thin layer of minerals and salt on top, which is the salinization. So in this lab, you will be testing the following salt concentrations on either radishes or wheatgrass. I've given you guys two options. 0%, which is just straight up distilled water, 0.5% salt, 1% salt, 1.5% salt, and 2% salt. So we have our different, and 3%, our different concentrations there, which I've already mixed for everybody. All the molarity calculations were done. You can thank Ms. Popoff for that. The whole problem for this lab, the whole central idea is how does increasing salt concentrations affect the germination of plants? So when we're talking about germination, that's where the seed starts to grow. All right, take a moment, and I want you guys to write a hypothesis. You can use the if then because format, anything along those lines, or your own format as long as it still covers everything. Maybe that's what you're gonna figure out. Oh my god. NaCl. sodium chloride. All right, anyone need more time for a hypothesis? Anyone want me to check their hypothesis?
Yes.
Cut? Good. Okay. Hold on. Leland's copy and paste yours in the chat.
Okay.
Yep. Okay, good. Isaiah, you wanted me to check yours? Okay. Yeah, hold on.
Look at me. You're going again.
No, that's been there.
That's such a weird word.
There you go. The water content of the water.
That's what's
Yeah, that's a good one. You've got both your variables, everything like that. All right, so what is your control for the experiment? Do you guys remember what control is? What would our control be? Okay. Or just, yeah, control variable or control in general? Leland temperature would be a constant. So I'm going to actually put that down here. Temperature would be a constant. Javea, you're really close when we talk about water. What type of water would be our control? What? What type of water would be our control?
The salt in the water, or the salt water itself.
It would actually be our one with no salt water. That's what we're going to compare all of our results to. We know plants can grow with 0 salt water. So we're going to compare it to how well they grow with no salt. But that does bring up the fact that the type of salt, which you guys had no control over, because I did it myself, is all the same. So everyone's using the same salt. What would be our experimental group?
Plant species.
Plant species would actually be down here. You're going to use all of the same species. You're not going to use 400 different types. What are we experimenting with? Salt water. Or 0.5 to 3% solutions. Sorry for the formatting, it really sucks. The soil one, where you had to partner up with somebody over the computer. We'll see about that. I would like to, but they have their own kids at home, so. All right, independent variable. Let's see. Test your memory. What is our independent variable?
The variable that the dependent variable depends on.
Yes, that was a good definition, Leland. It's our salt, or amount of salt. What is our dependent?
The one that depends on the independent.
What is the result? Good, germination. Okay, so that's what we're measuring. That's our result. So remember, our constants are the things that are going to be kept the same. We're going to keep the temperatures the same. The salt type I used, I didn't use like rock salt with one and regular table salt with another. It's all the same salt. You guys are going to use all the same plant species. Okay? Can you think of anything else that might go in here that's going to stay the same throughout the whole experiment? Light. You can keep the initial amounts of water. All right, so you're typically always going to have more than one constant, okay? So don't confuse constant with control. Control is what we compare things to. Constants are what stay the same throughout the experiment. All right. Anyone need that still? Okay.
Nope.
Don't worry too much about the materials. I have them out mostly for everybody already. I've pre-made the solutions for you. Last year they had to make their own solutions. It was a little scary. Those of you that are at home, there's two things slightly different about your kids than what they're going to have in class. One is I gave you 2 bottles. You probably won't go through both bottles, probably just one. The other thing is I gave you 2 different seed types. You're just going to pick one. So you guys have the seed types of a grass, which is the long and skinny seeds, or a radish, which is the little tiny, they look like nerd candy seeds. So pick one of those, but you have all sorts. Oh, and I didn't even see Dante's thing, containers. You can do whichever one you want. I don't even care. You could do both if your heart really desires, and pick one. All right. So procedure, this is what you guys are going to be doing today. You're going to test the following salt concentrations, 0, 0, 5, 1, 1.5, 2, and 3. You're provided with the NaCl, your salt solutions. Otherwise, you'd be calculating molarity. You're welcome. You're going to get 6 Petri dishes. You're going to label the 6 concentrations, so label your dishes. And for those of you in here, put your initials or something on them. So that way you know whose is whose, because they're all going to look the same. You're going to put 5 seeds in between the small paper towel in the Petri dish, and you're going to fold it over and kind of like soak it, which I think is the next step. I have matching pipettes with the solutions so you don't cross-contaminate. I've tried to color code stuff. Hopefully that helps. Everything with the same color belongs together. When you're drawing your salt solutions, do not draw from the bottom and maybe shake it up a little bit before you do. Otherwise, you're going to get a pure salt like sample. So you got to make sure the solution's mixed up and shaken up. Put the solution over the paper towels and the seeds. Don't drown it, but allow the napkin to absorb all the solution all over. And then you'll cover it, fold it over, whatever, and make sure that is soaked as well. Tuck in the edges so everything doesn't open up and dry out completely, and then place the lid on your Petri dishes. Okay? Those of you that are here, we're going to set the Petri dishes in the greenhouse. And keep yours together so you don't lose it. If you're at home, just make sure it's not in like some deep, dark, damp basement, you know, that's meant for living through World War II or something. What we'll end up doing after this is just making sure it stays a little bit moist, but we're not going to take data for probably a while. Most of these seeds won't even start to germinate for probably a week. So this will probably take all the way up to spring break. But feel, free to babysit them if you like. All right, is there any questions?
when we do this, are you going to show us how to do this?
I could probably try, or I'm gonna pull my computer and all the cords away, and I'm gonna walk around with my laptop, so we can watch another group if nothing else. All right. Okay, so we're gonna take some time to set that up. Those of you in here, it would be nice if you guys maybe chose a partner. Okay. And that would probably help out. And all right, I'm disconnecting my computer, so let's get to work. Oh, there we go. Come on over here so we can get your lab supplies while they stare up my nose or something. I don't know. All right, you have paper towels. You may have to rip or cut them. You have seed choices. Whatever you pick, I don't care. Just take 30 seeds. That's how much you'll need. Your Petri dishes here, markers to write on the Petri dishes, and all of your salt solutions. So they're all labeled. Like this is your control, your NaCl 0. Here's your pipette for it. You guys use these. No? Stick it in. Use the little wheel to draw water. Like there's 10 mils right there. Good thing it's not acid, right? If you want to release it, press the button. That's how you can wet your napkins. Or you can press it down. All right. So partner up, I don't care who, and get started. If I need to bring out more supplies, let me know. How many of these do you need? 6, because you have 6 concentrations. Yeah, you can, yeah. I have a little bit of a mess, but you can go wherever you want. I think it's 30 or 35. 30.
Miss P, if
Yeah.
you were trying to show us something, we couldn't see it. Your background blurs everything out.
I'm fixing that right now. I'm sorry.
Okay.
30 of 1. You can go anywhere here. You can go back to your desk if you really want, but I wouldn't trust it. Yeah. All the same. So you want 30 of the same seed. Correct. 30 of the same. So pick the one that you want, count out 30. They're just counting out seeds right now, so you guys can open up your seed packets. Yeah, we all have different ones. Can we look in partner? Yes, yes. Go for it. Yeah. Paper towel size.
I see a bunch of paper towels.
Yep.
Oh, there we go.
So count out your seed size at home. That's what they're doing.
That's better. Thank you, Miss.
I know, you needed a top. No, I didn't. No, this is the top part on it. Because this one needs a top. How many left? You might only need 2 better. 1 or 2 of the actual sheets, because you'll rip them up like you do.
Yeah, I got screwed up.
You could probably do mine, like rip them in quarters. It doesn't have to be. Look at you there. Look at you there. She's like. I think this is good. Yeah, what if she was typing? I don't think she is. No. Yes, you guys can cut the napkins up. I forget how much I gave you, but I like cut up Isaiah's right here or ripped it. That's why it's not straight. So then you'll put the seeds in there, fold it up, put it in your Petri dish and wet it.
All right, frick it. It's
Okay.
getting too frickin' annoying. Keep trying to type things in chat. So.
Great, I'm reading sideways.
20, 21. Javea, you can turn on your camera and unmute. That way we can be a normal class.
I highly recommend unmuting just so you can actually talk to people because it's much easier than trying to type and do this at the same time.
Good job.
I totally
you
agree.
You can disappear. That's what she said.
I might turn on my camera just to show off too, but
Never.
Oh my God.
Did you turn it 12? I forget that. Okay, now we have
12.
but my hair is also so like overgrown, so I don't want
Now
to do
we
it.
need to go cut a piece of the napkin.
Do it, Javea, come on. Talk to us.
Doesn't matter.
Dante, I'm doing the seeds.
Yeah, I'm doing the seeds too.
There are supposed to be 5, right? 1, 2,
Yeah,
3.
fuck it, why not? Pardon me. Never mind.
No, and it's like.
Oh, you know
Safe
this.
to tell.
Safe to tell. He
Safe
keeps
to tell.
saying he's
I have the
gonna.
number if you need it.
He's gonna report Mr. Disney.
He's trying to catch. How much do you need the water?
Just enough to get it wet. So I'm trying to
you have
do
to
one
fold
really
them with
quick.
the seeds in there.
Guys, don't forget the label. Put it in.
Yeah, they don't want that. I know you guys are a little eager to see. Yeah, we
Guys,
don't
hold
on.
Can you put the computer down a little bit?
Okay.
You
So
told me to fold. Look, you still fold halfway. You put the top on.
I got it. Yep. And then you'll go like that.
We want to put each of these on there, right?
You guys are okay. You guys got your marker. You guys are labeling. Make sure your stuff is labeled so you know which concentration goes where.
Fuck it.
You guys are pre-labeled. You guys have to label your own.
Hey, Miss, do you know how to crap out parts of the audio?
Say that again, Dante.
Do you know how to crap out parts of the audio?
I don't, unfortunately. My computer is maxed out right now.
Okay, because I think I might have let a couple not suitable for school words slip out.
That's okay. You're good.
Okay, good.
Totally good. I can barely hear you, and I have the laptop right next to me, so. All right. So I did one. I folded up my paper towel with my seeds in it. I wet it.
We do
Put
that
my lid
twice.
on it. It's labeled. I know this is my control.
30 seeds again, but at a different time, right?
No. 5 seeds in each. See? 5 seeds.
Why did you make so much radish?
Because I was just trying to, I was going to grow some too. 5 seeds in each. At least that's the control, so you're good.
Yeah. So we don't have to take it out?
Yeah, you do. There's not going to be room for that many to grow in one petri dish. Yeah, because otherwise they kind of roll around a bit. You can wet the paper towel a little bit, then put the seeds in and finish wetting it.
Or hearing that bigger.
All right. 5 in each napkin, huh?
But
Miss P?
You can fold it twice. I just did it all at the same time, but it doesn't matter.
Are we rolling them up in it? Oh.
Just kind of folded it over. It's really hard to do with one hand. But I just folded it over.
Miss P? How many drops go in each one?
Leland, as far as pipettefuls go, that one is 3%. So look for your 3%. Leland, just make sure it gets wet. Like it's not soaking. Here, let me take this off. Like I don't have it like full to the brim with water or anything, but it's wet.
Okay.
Yep. You won't even need a full pipette for that. Most likely.
My 3D printing stuff's over here. It keeps getting into petri dishes.
Remember, make sure it's shooken up. I don't know if anyone's used that one yet. Roll it.
Also, thank you for sorting these out. It would have been a pain to try and make these solutions by
I think I'm
ourselves.
gonna put in my headphones so I can hear you guys. Hold on.
That's probably a good idea.
That way you don't have to look down my ear canal. Okay. Hold on, Dylan. Tell me where you're confused. And Leland, you can do it directly onto the napkin.
Okay. Thank you.
Mm-hmm. Oh no.
Thank you for sorting these out.
What's that?
Thank you for sorting these out.
Yeah. Sort of. I sort of sorted them out for you guys. So.
The majority of the work. I really appreciate it either way, but.
I wanted to give you guys something you could do at home. This felt somewhat easy.
It's not really easy for me, but that's also just because I guess I'm lazy by nature or something.
All right, so Dylan, I have, hopefully you can see this, I'm dripping water all over my computer. Tech is gonna love me. I've got my napkin. I've got 5 of my, I put in radish seeds so they look like 5 little dots. And then I've folded it up once. And then I put it in my petri dish. Ooh, there's water everywhere. And I just wetted enough that like I don't have like water everywhere. Yeah, that looks good, Leland.
Quick
Yeah,
thing.
just hold on with your question. I have them color coded, Dylan. So like your red one is 3%. So use your 3% solution in the red dish. Blue is 1%.
And what is pink?
0.5%.
Them, like, is this controls and stuff? No.
The 0% is your control, the teal. Blue is 1%. You guys done? All right. So grab them and bring them into the greenhouse.
So do we need to bring these supplies back to you when we're done then?
If you don't want to drop them out, you can just put them anywhere. If you don't want to drop them off, Dante, I can come pick them up. Just set up a time with me.
Okay.
It'll be closer to spring break probably.
Yeah.
Anywhere on there.
I'll probably just drop it off to you. It's probably easier. So.
Okay. Yeah, I can do it either way. It's not like any of you guys live very far.
Okay.
All right.
Make sure. Yeah, so I draw it out.
Alright. You good?
Yep.
All right.
So far, so good, yeah.
All right. And then if you guys care, I just have them setting them on a table. Like that's all. They're all closed. They're all labeled, which your guys' is color coded. But ooh, it's there in Mr. Disney's classroom. All right.
Okay, there's two.
Yeah, we have to get the yellow and this one. Okay. Right? This one's our best one yet.
How is it your best one yet?
Because the rest of it, I did it.
Oh.
More than just one. That this one was hard to open.
Yeah. Oh yeah. Yeah. They said you and KK have to leave. 10:50. Yeah.
What time is the class?
20 after. So you'll miss the notes. Yeah, so today was just the setup for everything, and then in a week we'll come back and look and see if any germinated, and we'll do it for a couple weeks.
What exactly is germination?
No, so this Friday is the SAT for all of them. Yeah, and then so it'll probably be next week, either Thursday or Friday. We'll look and see if any. Yep, that's. It was the lab setup, and then we'll do some notes. So it's just section 5.8. Mm-hmm. Yep.
I feel like I'm ready for those as well.
What exactly is germination? I hear that term a lot. I don't understand what it means.
What?
Germination.
Germination, to germinate means to grow.
Ah.
So when a seed starts to germinate, you'll see like something like green poking out of it. And that's how you know it's germinated.
So I keep hearing that term. I'm like, I don't know what it means.
Don't stress, Ashley.
No, I am, because I'm so behind.
Oh,
Whose fault is it?
eh, but you can fix it. So. And, all right, so all yours are good and labeled. Yep. So
It's a little mess.
it's all right. It happens. So bring them back to the greenhouse.
I just realized I'm doing this over
I'm
power.
going to set them up. What'd you say, Dante?
But I just realized I'm doing this over a power outlet.
Kind of like how I was doing it over my computer and I got it all wet.
Pretty much.
Oh, we deleted and made room. We never
You
watched.
guys good? All right. Go ahead, take it into the greenhouse. You can
Speak.
see where everyone's laying their stuff down. Yeah.
I'm not sure if I have enough radish seeds for all of them.
Really? Did I not count yours well? 5 in each.
Not sure yet.
1 month before a year in Tanzania.
Ta-da, it's done. Can't see it.
Oh, nice.
Only versions of carrot.
That looks good. So just put your lids on, Dante. That looks good.
I was
What
afraid
are you
that was
doing?
overcomplicated or something.
I'm cleaning your bowl.
Oh, you're cleaning my board? Okay. You know there's a rag over there. All right.
I kind of wish I was in person just so I can have an excuse to draw on teachers' boards.
Oh my gosh. Yeah, you can see some of the board behind me. Like, they've been going crazy. And this is what it looks like clean, apparently.
I mean, it's pretty
Yeah.
fun, so.
All right, hold on. I'm reconnecting all my cords. Got so many.
Alrighty, I'm going mute again.
Okay. All right. Leland, Javea, Dylan, how are you guys doing with your setup? How close are you?
Good.
Okay.
I have 2 left.
Okay.
Just trying to make sure I don't make a mess.
All right, good. All right, I'm going to switch back to regular speakers. So while the last couple people are still setting up and they're going off over there. Oh, you can just put it on the counter. Thank you, Devon. So like I said, they're just going to stay sitting there. It's going to take a while for them to germinate, to start to grow. Probably next Thursday or Friday, we'll look at them again. Some of them will probably have started, some not. And then we'll talk about measuring and recording and all that stuff at another time. So this at earliest is probably going to be, it says day 2, but it's day 2 that we're doing it. This will probably be next Thursday or Friday, just to kind of give a heads up. All right.
Was there a 2.5?
What is that again?
I said, was there a 2.5?
No 2.5, just 2 and 3. Yep. Yeah, you guys were on the list. Yeah. See, I'm smarter than I look, KK. All right, bye guys. All you're gonna miss is notes and like to do the progress check at DOL for homework. That's it.
Can you know our logins for the passport?
I do. I can look up your emails, I think, but not your logins.
Okay.
Sorry.
I saved on my computer, then I got a loaner.
Oh.
And I don't remember it.
No.
Then I had to save it on my phone.
But I
reset my phone.
Oh no. Yeah, I can look up your email. Yeah, I do too, KK. I learned that the hard way though.
Where do you keep it?
In a secret place.
Keep it on my whiteboard, on my schedule whiteboard.
Don't tell people where you keep your passwords, KK.
My schedule whiteboard.
Right.
I do something. Yeah.
Oh my gosh. Y'all are too much.
Can I just
When you
sit
see
here? I
some
swear
guy
I
with
don't wanna
glasses creeping outside your window, now you know.
go. Look at my sis, Mom.
What's wrong with glasses?
All right.
Actually, I have to go to the auditorium. Thank you very much. Don't be jelly.
Oops.
Hey. Don't be jelly.
Bye. See you guys. All right. So while I'm getting everything hooked back up, pull out your note packets. We are going to go through 5.8, hopefully. This is also the section I kind of want to do a video on because it's kind of gross. And that makes it kind of fun.
Ooh, are we gonna watch the inside of the slaughterhouse?
It does have part of that, yeah.
You know what they do? You know how they tell sheep and I can't remember what my stepdad said, but I think it was like Pakistan or something like that.
Mhm.
Somewhere in the Middle East.
Yeah.
They kind of herd it into like a little, kind of like a small little enclosed area, right?
Mhm.
like in one of the walls there's a hole, right? Eventually, one of them like stick their head through the hole, and then they just come down with a camera, hit them on the head.
Yep. It's a little interesting. All right. Yes. What? Holy crap! You really are cleaning my board.
I'm erasing credit because you seen the mob.
Oh, that's hilarious.
On it.
Okay, that works. All right.
Put them in the sun somewhere.
Say that again, like, sorry.
What'd you say?
Oh, I was talking to Jesus. He's trying to get beat up here at school by some girls. All right, so this little section is on meat production, just like Isaiah and I were just talking about. We're going to watch a quick little clip, Meat and You, Partners in Freedom, and we're going to talk about meat production in the U.S. I know it seems weird that meat production doesn't sound very like environmental, but it is big time environmental.
A family vacation in a Verbo means leaving all the craziness behind. Well, maybe not all of it. Crazy feels good.
Nothing beats a stroll in cattle country. Hi, I'm Troy McClure. You may remember me from such educational films as 2 minus 3 equals negative fun and Firecrackers, the Silent Killer.
Mr. McClure?
Oh, hello, Bobby.
Jimmy, I'm curious as to how meat gets from the ranch to my stomach.
Whoa, slow down, Jimmy. You just asked a mouthful. It all starts here in the high-density feedlot. Then when the cattle are just right, it's time for them to graduate from Bovine University. Come on, Jimmy. Let's take a peek at the killing floor. Don't let the name throw you, Jimmy. It's not really a floor. It's more of a steel grating that allows material to sluice through so it can be collected and exported. Getting hungry, Jimmy?
Mr. McClure, I have a crazy friend who says it's wrong to eat meat. Is he crazy?
No, just ignorant. You see, your crazy friend never heard of the food chain. Just ask this scientician. He'll tell you that in nature, one creature invariably eats another to survive. Don't kid yourself, Jimmy. If a cow ever got the chance, he'd eat you and everyone you care about.
Wow, Mr. McClure, I was a grade A moron to ever question eating meat.
Yes, you were, Jimmy. Yes, you were.
You're hurting me.
They can't seriously expect us to swallow that tripe.
Now, as a special treat courtesy of our friends at the Meat Council, please help yourselves to this tripe.
Gross. Okay. There's your introduction. That is not necessarily wrong about the meat industry. It is essentially how it is. There we go. All right. So in your notes, took me that long to get organized. When we're talking about efficiency of meat production, it takes about 20 times more land to produce the same amount of calories from meat as it does from plants. And so 1 kilo of food beef is the most intensive. You need over 30 meters squared. Pork and chicken are pretty close. The eggs, although that goes along with chicken, I'm just saying, kind of weird. But when you look down at fruits, potatoes, and vegetables, you need so much less land in order to create 1 kilo worth of food. So it is very intensive when it comes to land use, which is what we're talking about. Some of the surface allocation or area for food production, when we're talking about our entire Earth, 29% of our Earth is land. Of that land surface, 71% of it is habitable. So like not living at the top of Pikes Peak would not be habitable. 50% of that land is agriculture. 77% of agriculture lands gets used for agriculture, and it keeps kind of breaking down. So that's what that's showing you right there. When it comes to water efficiency, it takes about 10 times more water to produce the same amount of calories from beef compared to plants. So you can see up here, this amount of water is used to raise cattle versus the amount you would need for like soybeans or even eggs. 20 times and then 10 times. All right, high density animal farming or feedlots. You often see them referred to as CAFOs, which means concentrated animal feeding operations. It's kind of like the abbreviation for them. You typically see them with beef, cattle, dairy, since there's different cows for each of those. Hogs, your bacon, Mr. Bacon Burger, and poultry, your chicken. So this is what those CAFOs look like on the inside. They're very confined. They're allowed very little room for movement for all or part of their life cycle. You can see in this top one, all the pigs confined to one pen, how many cows are in a certain area. Another thing that the industry will often get criticized for is the use of antibiotics. So if they give a dairy cow antibiotics, those become part of the milk and become what you drink. So whatever the cows ingest, you essentially ingest too. They also often get nutrient supplements to minimize diseases and malnutrition. So almost kind of like piggy protein shakes. Some economic benefits of these CAFOs. Leland, I could argue either way on that, whether or not any of that helps us. People blame that for us not being able to produce or ingest them naturally. They also blame stuff like that on because they give cows like growth hormone. And why generations are now getting like taller and taller and taller. So if you're taller than your parents, that's one thing they blame it on. So it could go either way. Some economic benefits from it. It minimizes your land cost if you're doing a CAFO because everything's so concentrated in a small area. It improves your feeding efficiency. So you have very little places you have to put your feed out to. Increases fraction of food energy that goes into the production of animal body mass. So there's not a whole lot that they have to do in order for the like pigs or the cows to gain that body mass before they go to slaughter. What are you eating? Not sharing donuts. It's alright. Hey, don't look. You got a hamburger or bacon burger.
Yeah, I'm not eating it now.
I know. That's true. All right, we've got a few different drawbacks as well. The first one being that a bunch of bacteria, including resistant bacteria, tend to become resistant to those antibiotics. All right, and then that resistant bacteria multiplies, becomes more common, and eventually evolves into a new resistant strain. They have, what is it, the antibiotic resistant MRSA. So if you've ever been into like sports and wrestling, that type of stuff, MRSA is something that gets around pretty easily. There's an antibiotic resistant version of it. Oh, I forgot to put number 1 up there. Sorry, guys. You're just typing the antibiotic resistance, not all 4 of those things. Sorry.
Oops.
Sorry. That's my fault. That's my fault. Just type antibiotic resistance. I just realized that there's 4 things up there and like 5 bullets, and I was like, that's really close. All right, number 2 is diseases like mad cow disease. This was really rampant. I think when I was about your guys' age in high school, there was a really bad, like nationwide cases of it. So mad cow disease, if you don't know that one, that's where you get like, it came from like cows eating cow. So don't eat, I guess don't be cannibalistic.
Actually, I read up on it. It was lamb sheep scratching themselves on barbed wire, and the cows ate that.
It can come in different ways, but that I didn't know that one was one of them. You get like brain shrinkage and deterioration from it. That's where you get like some mental like issues, and it like you start to regress. And this is what it kind of does to your DNA, or not your DNA, the cow's DNA. Healthy protein folds in on itself like corkscrews. When you have mad cow disease, it leaves something unfolded, and it doesn't like bind back up and replicate appropriately. And then that's what causes damage. Number 3 is waste disposal. Is a drawback. The average CAFO produces the amount of manure a town of 5,000 humans would produce. The nutrient runoff, because they don't have a sewer system for these cows, goes right into the waterways and into the groundwater that we drink from.
Ew.
Yeah, right? One of the videos I want to watch with you guys, I think it's called, it's either Little Big Farm or Big Little Farm. I don't remember what order that goes in, but they taught, one of the things they talk about is a pig farm, and it gets really gross. That's not the way I'd want to get the nutrients. Just throwing that out there. All right, number 4. Oh, I forgot I have this first. This is where you can see the CAFOs, the buildings where they house all of it. All of that, they have like an open ditch that runs along where they drain it into, that gets into the stormwater runoff, which drains into the pond, and then it also seeps down into the groundwater, and it can go out towards lakes, rivers, you know, the places you go swimming in, stuff like that. So that's kind of what a CAFO site looks like. And number 4 is the ethical concerns. We were just talking a little bit about here. Never going swimming again. And what it is, the quality of life versus, you know, how much money you make off of them. You tend to get a lot of aggression, even though species aren't necessarily territorial. Like the chickens will start trying to kill each other in order to get space. Because they're not happy. So, or leaving pigs chained up like this full time for their entire lives. They poop, they eat, everything right there. They can't even turn around. So there's definitely some ethical concerns to it. The 5th one, the last one, is the nutritional content of food. We are omnivores by trade, so we do need both of them. However, when it comes to what those animals eat, there's different nutrition between grazing from grass in a pasture versus grain, and all the antibiotics, more fat, less nutrients. So your grazing cattle tend to be a lot healthier than they do with grain-fed animals. So nutritional content can vary. All right, free range grazing. I have one of these across the street from where I live. It's kind of cool to see cows in the morning. They have rangelands. They're typically dry, open grasslands used for grazing of cattle. This is the most common use of land in the U.S. because it's grazing, so they have to move around seasonally. But otherwise, they'll just eat all the grass, and you have your tragedy of the common scenario where there's nothing else left for anybody. This is a really common land use, and here in Colorado, even, we have a ton of free-range grazing cattle. Oh yeah, definitely on the way up to Denver. Some of the rangelands throughout the world, again, you're going to see it along with residential. Even here in Colorado Springs, we have it. Keep going, because I don't think I have to do anything. Nope. All right, some of the benefits of grazing, because there's good and downsides to this as well. The ungulates, or the hooved animals, can be raised on land that is too dry to farm, so otherwise might be useless land, but they have no problem grazing. Less fossil fuel energy than feedlots, so it's a lot less like machines and gates and all of that stuff. You throw up a fence and you call it good. It's a little more complicated than that, but essentially that's what I'm rolling with right now. All right, everyone good? Okay. Some issues, environmental issues related to it, is the vulnerability to fires, because it's arid land, it's dry land, which is definitely one of our issues here. Yeah. And I mean, it does take time to naturally come back from a fire, which they're generally healthy for an ecosystem. But as far as grazing land, it's toast for a couple of years. You can't use it at all. Stream bank erosion. Cows are notorious for causing issues with streams. They're heavy hoofed animals. They knock down the banks. They get sediment and poop and all that stuff into the waters. And third, the pollution, which I was just kind of leading into. You can see how they would degrade some of that stream bank. And then poop and pee in it, so everyone can go swimming. I mean, fish already pee in it, so it doesn't matter, I guess. But it gets really gross. They also knock up a lot of the sediment that's settled at the bottom of the streams, which creates turbid or cloudy water. Which means things that were used to getting light at some point no longer get it, and so it can kill off the microbes and some of the smaller animals and plants living at the bottom of the streams. Overgrazing, so it leaves no land exposed, and it gets exposed to wind erosion. That soil can no longer absorb or retain water, and therefore it just basically kills the land. All right. As far as biodiversity goes, you have before grazing, you have a pretty high groundwater table. You have these are all like different species like birds, butterflies, rodents, turtles. Yeah, I think there's a snake in there somewhere. Grubs, dragonflies. Oh, there's the snake right up there. All of that type of stuff. And then after a heavy set of grazing, if they're not rotated, you start to really lose most of that biodiversity, especially as far as trees and shrubs go, and your water table will generally drop as well because those trees and shrubs are dying off and not pulling that water up. All right, but who is the fancy pants that determines soil conditions? We have a couple different environmental organizations that will classify soil, which weirdly enough is like one of my favorite things to do. Up to 55% of U.S. rangeland soils are in poor condition because of the overgrazing. So that's quite a bit, over half of them. Poor soil is considered no nutrient availability to hold moisture. You could actually ask Mr. Disney about that because he tried growing some lettuce and radishes last year in the greenhouse without testing the soil first, and they all died because they had no nutrients and the water would just right through. Right? And he's the one that can actually grow things. I kill everything. Yeah. BLM is one of the ones that, what's it called? Does a lot of this. BLM being Bureau of Land Management. Right, that is so true. And then you have like sub-agencies and it just gets to be a mess. Oh, the next one. Taylor Grazing Act is your next blank. So the Taylor Grazing Act of 1934 is where converted federal rangelands, federal rangelands from commons into permit-based grazing systems. So commons being whatever everyone can use it to, you need a permit to use it. It might be free, it might be cost money, things like that, but this way they're tracking who is using and how much to avoid a tragedy of the commons kind of scenario. You know, some people say it's a bad thing because the low cost or the free permits continue to encourage the overgrazing. But one of the things, the government does spend a lot of money, 7 times more money on management than it receives. So essentially that's saying the government subsidizes or pays for the ranging land.
Really big environmental problem, and they have to go through all these agencies, and that's a mass. And by the time the problem is over, it finally gets to the top where they are like, oh yeah, do this.
So we'll actually discuss that because that does happen, especially with like Superfund sites. But when we start getting to units 7 and 8, it's all about pollution and contamination of air, water, and land. And that's a really big issue. A lot of red tape. And sometimes it works out. Sometimes it's a little bit too late. I would agree with you on that. Here's just some more information on the Taylor Grazing Act. I am going to try and skate through it, though. You guys can read it on your own time because we're almost done. BLM regulations. Let me get my log in a minute. Okay. BLM regulations, they tend to focus on watersheds, so kind of the big picture, habitat restoration, and ecological protections. A lot of hunting land is even on BLM land. However, there's no requirements to involve environmental scientists, and state and regional managers are given a wide latitude, a wide range for their guidelines and standards. And it really varies by state heavily. Will you go in the cabinet, pull out my backpack? It's on the right side. And bring it to me. Yeah, I'm not needy. Hey, Dustin. Yeah, go for it. And yes, Leland, it does exist.
Do we know that? Do we know that?
Yes, I do. I've known people to be stationed there. I have 5s and 1s.
Oh, that's fine.
That's fine?
Yeah. Somebody's gonna go get me food, and I don't want to pay them money because it doesn't.
I don't have. That's all I have 18. So I can owe you $2.
Don't worry about it.
Okay.
That's fine. You can have $2.
I'll pay you back somehow. All right. Last slide, I believe. Oh, you're not done? Sorry. Oh. Hey. Dusty. There you go.
Have you like done this to that place?
What?
You don't, wait, you don't
Yes.
You did not help. No, you didn't.
You can't be talking and telling me to hold on. Oh my God. Jesus. Need some Jesus in your life. All right. So why reduce meat consumption? So not net, or at least this is why you've seen a big push by some of the fast food restaurants for plant-based meat. A lot of this is why. So reducing meat reduces carbon dioxide and nitrous oxide, which are greenhouse gases. You conserve water, reduce the use of antibiotics and growth hormones, improve topsoil. And of course, we talked about the ethical concerns of animal treatment with like the CAFOs. So there is the last little bit in your packet is a link for the Clive Bundy standoff, where the guy was like trying to protect his land against the U.S. government, and there was a shootout and everything. It was pretty recent, within the last 10 years. I forget exactly when. But that is it for today. I will maybe see you guys Monday, maybe Tuesday, depending on whether or not tomorrow's a snow day. Right? Bye.
Bye, Miss. Bye, everybody. Bye, everybody.
Bye.
Farewell.
Bye, Dante.